This is the only class of the chapter Applications of Integrals, and this is the first chapter being covered from section B. Now, this chapter has nothing much to discuss about, so we are just going to discuss the whole chapter through problems. So we'll be taking few problems and we'll be solving, and yes, that's it. That's what basically this chapter is. So let me just run through some ideas before we go into the problems. Now, the things that which we are going to discuss is basically area under the curve. Now, integration is described as area under the curve, then area bounded by lines when the curves are actually lines, then a curve and a line, and then between two curves. So basically that's how we are going to do it. So what basically is area under the curve? So if I'm having a function y equals to fx, and I'm trying to find the area under the curve from x equals to a to x equals to b, then that area is represented by integration a to b fx dx, right? Now, if instead I have two curves, so if I'm trying to find out the area bounded between the curves from x equals to a to x equals to b, then the area is represented by integration a to b fx minus gx dx. Fine. So that's what the theory of this chapter is. That's how simple it is. So now we will be taking up different problems and solving. So let me take the first problem. In the first problem we have, using definite integrals, find the area of the triangular region whose sides have the equation y equals to 2x plus 1, y equals to 3x plus 1, and and x equals to 4. So our first job will be to plot this curves. Now, once we plot these curves, you can see this is what you get. Now, obviously, this plotting need not be done on a graph paper. This plotting has to be done roughly along with the problem, and from the plotting, this is the area, this is the triangular region whose area we are trying to find out. Now, to find out the area, first we need to know what are the points of intersection that we have. Now, the points of intersection are 0, 1, 4, 9, and 4, 13. So this is how we are going to go through the integration. So you see this point is, let me change the color a little bit. Let me take a black. Yep. So this point is 0 comma 13, I mean 0 comma 1, and this point is 4 comma 13, and this particular point is 4 comma 9. So 4 9. So now we can see this integration will run from the value of x 0 to value of x 4. So the whole integration will be from 0 to 4. That is what our integration is going to be. And what will be the integration? Now, obviously, the curve or the line which is above minus the curve or the line which is below. Now, the curve which is above, that is your 3x plus 1, and the curve which is below is 2x plus 1. So it will be integration 3x plus 1 minus 2x plus 1 dx. So that's basically what our integration is. So now let me just write it down fresh. So this is what our integration basically is. Integration 0 to 4, 3x plus 1 minus 2x plus 1 dx. So everything cancels, it becomes integration 0 to 4 x dx, and that is x square by 2 from 0 to 4, and that is 8 square units, right? Then let us move to example number 2. Example number 2, we have, using integration, find the area of the triangle ABC. The coordinates of the vertices are 4, 1, 6, 6 and 8, 4. So this is just the reverse problem of question number 1. Here the vertices are given, you are not given the lines. So our first job will be to find the equation of the lines. So I mean the sides of the triangle. So A, B, C, these are the 3 points. So let us find the equation. So what is equation of AB? Now obviously when you are given 2 points, we know using the point form we can find the equation of line. So equation of line is y is equals to 5x by 2 minus 9. Then equation of BC is y equals to 12 minus x, and equation of AC is y equals to 3 by 4x minus 2. Now obviously you need not show them separately how you are getting the equation, because now it is pretty obvious and clear that you are going to get the equation in point form. Fine. So now let us draw the graph. Let us draw the graph of the function, I mean the lines. So these are the lines that we have. So you can see the triangular region, and also let us mark the vertices A, B and C. Now how to do this integration? See, here we are going to draw these 3 straight lines which are marking the regions which we are going to consider. So if we just zoom in a little bit, so here it is easy for us to understand. See, this point is x equals to 4, this is x equals to 6. So from 4 to 6, I am going to integrate AB and minus AC. Oh God, I am so sorry. So I am going to integrate AB minus AC from 4 to 6, and from 6 to 8 I am going to integrate BC minus AC, because BC is above AC, and similarly AB is above AC. So therefore this is basically the integration that we have. Now let us put the values and calculate. So from 4 to 6 I have this 5 by 2 minus 9 minus 3 by 4 x plus 2, and 12 minus x minus 3 by 4x plus 2. So once we simplify this down, we have 4 to 6, 7 by 4x minus 7, and this is 14 minus 7 by 4x. Upon integration, we have 7 by 8x square minus 7x and 14x minus 7 by 8x square. And if we put the values and calculate, our answer is 7 square units. Now obviously if you want to verify if you have got the correct answer or not, you can always do what? You are already given this 3 points. You can use the point formula for finding the area of a triangle, or you can use the determinant formula as well, that is half of x1 y1 1 x2 y2 1 and x3 y3 1. So you can make use of this to verify if you have got the right answer or not. Fine. So that's it. This is problem number 2. Now let us move to number 3. Problem number 3. Now here we have a straight line and a circle. Find the area bounded by the circle x square plus y square equals to 16 and the line root 3y equals to x in the first quadrant by using integration. So let me first draw the figure. Now it is told that I am supposed to find only the area bounded by first quadrant, so I am not shading the portions which are beyond first quadrant. So this is the area that which we are going to find out. Now, to find out the area, the first thing that we need to do is to find the point of intersection. So upon solving simultaneously, we get the point of intersection as plus minus 2 root 3 comma 2. Now obviously you can see if I take negative, then it is going to go into the third quadrant, so we are not going to consider the negative, we are going to consider only the positive, because we are limiting our discussion only to first quadrant. Then after we have found out the point of intersection, now let us understand what the area is going to be. So let me just zoom in a little bit and understand. So this is our point of intersection, this is our point of intersection, and this point is 2 root 3 comma 2. So our integration will start from 0. Obviously this is 0 comma 0, so our integration will start from 0. So at this point 2 root 3, and remember what is the equation of the circle, it is x square plus y square is equals to 16. So therefore the radius is 4, so at this point it is 4, so this point is 4 comma 0. So therefore our integration will be from 0 to 2 root 3, where we are going to integrate only the straight line, because that portion is only covered by the straight line, and from 2 root 3 to 4 we are going to integrate the circle. Fine, so that's exactly what we are going to do. So now let us write the integration. So therefore the area is given by this. Check it very carefully. From 0 to 2 root 3 we are integrating the straight line, and from 2 root 3 to 4 we are integrating the circle. Now let us put the values and calculate. Now if we do the integration, now root over of 16 minus x square, the integration, it is x by 2 into root over of 16 minus x square plus 8 sine inverse x by 4. It's a big formula. Now obviously the main part of the calculation of this kind of a problem is that after the integration is done, putting the value and calculate. So that is the only troubling part of the problem. Otherwise these problems don't have much in it. Now the calculation will become a little bit, cumbersome and complicated. If you do it carefully, you won't be having problem. So I have done the calculation. I am not showing the calculation separately, so you can understand what you are supposed to do. So once you do your calculation, you get the answer 4 pi by 3 square units. And yes, obviously do not forget to write square units, because you are finding area. So whenever you are finding area, you must have an unit, and area units are always in square units. Now problem number 4. Find the area bounded by the curve x square equals to 4y and the straight line x equals to 4y minus 2. Now x square equals to 4y is basically a parabola facing upwards, and straight line is given x equals to 4y minus 2. So let us first draw the graph. So this is how the graph looks like. Now we are supposed to find out first the points of intersection, which are very important. Now if you solve simultaneously, you will see that the points of intersection coming out to be 2 comma 1 and minus 1 comma half. Now obviously the extent of x coordinate is from 2 to minus 1 to 2, so therefore the whole integration is going to be from minus 1 to 2, and we can see the straight line is above the parabola, so therefore the integration is going to be the straight line minus the parabola. So therefore the integration becomes minus 1 to 2, the straight line minus the parabola, and upon integrating we get the area to be 9 by 8 square units. Do give it a check. I have done my calculation, but I may be wrong. I hope I am not, but still just give yourself a check. Do it all by yourself and verify. Next one. Number 5. Using integration, find the area of the region enclosed between the circles x square plus y square equals to 4 and x minus 2 whole square plus y square equals to 4. So if you draw the circles, you will see that x square plus y square equals to 4 is a circle with center at origin and radius 2, and x minus 2 whole square plus y square equals to 4 is a circle with center at 2, 0 and radius 2. So if you draw these two, you can see the overlapping region where you need to find the area. Now obviously the area will be between, if I just zoom in a little bit, the area will be between 0 to 2, the integration will be between 0 to 2. From 0 to 1, I will integrate the circle with center at 2, 0, and from 1 to 2, I will be integrating the circle with center at origin. Now obviously this will give me half the area. So therefore I need to multiply it by 2 to get the total area, as the figure is symmetric. So therefore, let me just write things down like this. So and yes, obviously, how to know that this point is 1? Because the point of intersection comes out to be 1 comma plus minus root 3. So therefore I know that the points where both the curves intersect, the x coordinate is 1. So now let us write down the integration. So as I told you, from 0 to 1, I will integrate the circle with center at 2, 0, and from 1 to 2, I will integrate the circle with center at origin. Now this is only giving me half the area, so I will multiply it by 2 to get the total area. Now you can see both the integration will be a little bit, not little bit, it will be huge. And so if once you do the integration, then putting the value and do your calculation, and after you have done the calculation, you will see that the area comes out to be 8 pi by 3 minus 2 root 3 square units. So that calculation part I am just leaving to you, because you all need to put the values and calculate. So that part I am pretty sure you will be able to do it. Next, number 6, and this is the last problem that we are going to consider. Find the area of the region bounded between y square less equals to 4x and 4x square plus 4y square less equals to 9. Now obviously y square less equals to 4x is basically the parabola and its inside region, and 4x square plus 4y square less equals to 9 means it is the circle and its inside region. So therefore the area that which we are talking about is this. So I have a circle and I have a parabola, and I am trying to find the area bounded between these two figures. Now again, the idea is basically the same as the previous problem. First we need to find out the points of intersection of these two figures. Now if we just solve these two figures simultaneously, solve the whole thing simultaneously, we'll see that the points of intersection coming out to be half comma plus minus root 2. Now obviously the circle has got a radius of 3 by 2, that is 1.5. So our integration will be from 0 to half and from half to 3 by 2. So this is basically what the integration looks like. Now if you have not understood, let me just clarify it for you. Now this is 3 by 2, this point is half, and this is 0. So therefore from 0 to half I am going to integrate the parabola, and from half to 3 by 2 I am going to integrate the circle. So that's basically how we do it, and obviously again I need to multiply it by 2 because it is giving me only half the area, right? So now let us come back. So now once again we all need to do is to integrate and put the values, and as you can see the integration looks a little bit scary, but not that scary that you won't be able to do it. because the integration part is all the same. It is very simple. You just need to put in the formula. You don't need to do the integration like you have to show all the steps of integration, as this chapter is application of integrals. So here showing the integration is not much important. Just writing the correct integration is important. So if you have managed to write this step correct or not, that is more important. Reaching to this step, how you if you just put direct formula and write the step, then it is absolutely fine, because nobody is expecting you to show the steps. Now after you have done your integration, right, it's time to put the values and calculate. Now if you do the calculation, you will see that the answer is coming out to be 1 by 3 root 2 plus 9 pi by 8 minus 9 by 4 sine inverse 1 by 3 square units. Now for an answer, this is a very bad answer. As you can see, the expression is quite complicated, but still consider this, that this is definitely your answer. Fine. So that's it. That is our class. We complete the first chapter from section B, that is application of integrals. Thank you.